AI Ethics, Introduction and History. When we left off with Sandel, we saw that justice is about rightly distributing that which we value, and that which we value depends in part on the sort of society in which we live. What we value depends, again in part, on the possibilities that we have inherited and how those possibilities play out. The possibilities for employment that are open to us, the skills that we choose to develop, the things that we choose to purchase, the time we choose to spend, and the trade-offs that we are willing to make depend upon these possibilities. AI is transforming our society. It is also transforming what and who we value. Think back to Sandel's clip on meritocracy. One of the issues of justice that he brings up is that the qualities that we value are often out of line with the actual value to the common good, or eudaimonia. The fact that some people just happen to have a skill set that the market is clamoring for does not necessarily mean that they deserve the honors that they are given. This is nothing peculiar to an information society, let alone one dominated by AI. But we should explore what sort of things we will come to value in such a society and whether that evaluation is just. So what is AI? Well, it's an initialism for artificial intelligence. We have a pretty good idea of what it is to be artificial. Silk is natural, satin is artificial. We know the difference between a natural and an artificial Christmas tree. Intelligence is another matter. Is a dog or cat intelligent? Is the computer that can beat you at chess intelligent? And what about chatbots? First, we need to distinguish between intelligence and consciousness. In the late 17th century, the philosopher Wilhelm Gottfried von Leibniz came up with what we now call the parable of the mill. Imagine a huge machine that can do all sorts of tasks, sort of like a computer, but one that you can walk around in. Your job would be to find where the consciousness of this machine is. Now, in Leibniz's day, he would have pointed out gears and belts, but we can do the same thing with electrons moving in and out of CPU registers. Try as we may, we will not find consciousness. It doesn't mean that the machine is or isn't conscious, only that whatever consciousness isn't like gears, levers, or CPUs. Intelligence is another matter. If someone says something insightful or solves a tricky problem, we would generally say that that person is intelligent. Intelligence, unlike consciousness, is a behavior or a set of behaviors, and machines can behave intelligently. So where do we see AI? Well, just about everywhere, often hidden in plain sight. Search engines use AI to interpret so-called natural language. That is, the way you and I normally talk. 30 years ago, if somebody wanted to do a search on AI, one would have to issue a command something like this. Find in subject artificial intelligence or AI and date greater than 2019.12.31. It took some training to know all the tricks to get the best results. Now we can Google AI since 2019 or any variant on that. Besides that, search engines can guess at what we want based on past searches. So two people using identical terms can have different results that are customized to what they anticipate they need. This sort of analysis can also be found in sites such as Amazon and various streaming services. They are able to do this by a deep analysis of all the activity on their sites and the data associated with your web browser. AI depends on data, lots of data. While personally identifiable information is stripped out or firewalled, the sheer amount of data available about individuals is enough to target users for retailers and other actors. The balance between convenience and anonymity or privacy is a reflection of what we value. It is also worth keeping in mind that these services, and here we can include news feeds, are not primarily about informing us but keeping our attention. They are designed to drive revenue, not enlightenment. The virtue theorist might object to this sage, since these services are not in the business of eudaimonia, but commerce. Virtual assistants such as Copilot and large language models such as ChatGPT or Gemini also depend on large amounts of data. Autonomous vehicles also consume a large amount of data, both in navigating their surroundings but also in obeying the rules of the road, a skill they must learn. Autonomous vehicles hold the promise of improved safety and efficiency, particularly if societies move from treating cars as something that one owns to a service that one subscribes to. However, the same technology that can be used for civilian purposes can and has been militarized. The issue is just when is it permissible for a human being to relinquish control within an ethical situation? Finally, AI is found in everything from facial recognition to criminal sentencing to job placement. Issues around these technologies will be something that we will look at in more detail when discussing bias in AI. AI can be divided into two types, general or strong AI and narrow or weak AI. General AI can perform all the sorts of cognitive tasks that human beings can, and likely better than humans can. Narrow AI can perform narrowly defined cognitive tasks, in many cases better than humans, but not always. Everything that we have looked at so far has been an example of narrow AI. And what about general AI? There are no examples, and depending on who you ask, we might see general AI in 10 years or perhaps never. We will certainly not see it with the techniques we are using now. If one pushes AI back to ancient times, at least to mythology, we can find it. However, let us start with Vandermeer Bush. In 1948, Bush conceived of a large filing cabinet that could hold vast amounts of data. In his day, this data would have been stored in microfiche and printed in miniaturized transparent film. The trick here was that users would call up what they wanted and the cabinet would retrieve it. In the 1950s, there were a series of conferences at Dartmouth College. It was here that the phrase artificial intelligence was first coined. Between the advances in computer science and progress in logic, which easily could translate human language into mathematics, it seemed as if the goal of artificial intelligence would be a reality by the 1980s. The way artificial intelligence was conceived at that time was what Kohlberg called symbolic manipulation. Basically, we were looking at a sort of procedural instructions on which we would find a basic course of logic. One of the most basic of which would be if, then, or else statements. For instance, you could construct something that looks like the following. If finished with assignment by 4 p.m., then go to party. Else, stay home and continue studying. Calling this intelligence has been criticized on a number of fronts, perhaps the most famous being that of John Searle's Chinese room. Imagine you are in a room entirely enclosed, save for a slit. In the room are paper, a brush, and a book. The book provides instructions on how to respond to any request written in Chinese. You don't know Chinese, however. Every now and then, a piece of paper is dropped into your room with some Chinese characters. You look up the characters and with the brush and paper, copy the response found in the book. From the point of view of the person sliding the request through the slot, you know Chinese. From your vantage, no matter how many times you perform this task, you will never know Chinese. It would seem that a purely procedural method of manipulating symbols is not enough to count as intelligence. Searle's point is that intelligence requires understanding and that this procedural method doesn't provide understanding. Symbolic manipulation is still used in some cases. There is a technique called expert systems where experts detail the procedures they use and create a sort of decision tree which looks like the flowchart found on the side. By the 1980s, a new technique came about. With distributed computing, it became possible for several computers to handle small tasks or to handle the same task multiple times and compare results. From here, there was something called neural networks, where each computer was given a small task to evaluate, and the system as a whole generated a probability for a certain outcome. This technique is known as deep learning. With deep learning, there are two ways to arrive at outcomes, supervised and unsupervised. Say you have millions of pictures of cats and dogs and a few pictures of things that are neither. You could train the AI to sort these pictures into three groups, cats, dogs, and everything else. This is supervised training. Now, let's say you wanted to train your AI to classify cloud types. You could list all the cloud types and feed thousands of images to train it and then let the AI classify the rest on its own. Or you could feed it millions of pictures and have it come up with its own classifications. Having the AI come up with the classifications on its own, that is, this outcome, would be unsupervised training. One thing to keep in mind when discussing AI is that it is not a single entity. AI is programming, but without the data, the programming is worthless. You can have a powerful large language model, but it won't tell you a single thing without a phenomenal amount of data. How AI evaluates this data varies with the programming. Programming suitable for a large language model, such as Gemini, won't work for autonomous vehicles. ChatGPT has many uses, but driving a car is not one of them. While on the subject of self-driving cars, AI is also hardware. The inputs and outputs of an AI depend on the hardware used. The software that drives autonomous vehicles is worthless without the right array of sensors or hardware necessary to activate various automotive functions. The same hardware would be pointless with ChatGPT. Finally, at least for the time being, AI requires some sort of human intervention. AI doesn't create. Whatever it learns does not go beyond the data that is fed to it. And at least for the time being, AI doesn't innovate.